Let's dive in. Today we are really unpacking the world of EEG devices. The tech that listens in on your brain's electrical activity. And we're using this fascinating online tool as our guide. It pulls together a lot of data comparing different devices out there. So our mission today is basically to explore what this data shows about the whole landscape of EEG tech. And maybe more importantly, how a resource like this can help you make sense of it all.
Right. And understanding those differences is becoming really crucial. I mean, this field is just moving so fast from hospitals to consumer gadgets to
Yeah.
cutting edge research labs. So whether you're actually trying to pick a device or maybe just understand a study you read or, follow the tech news,
Yeah.
seeing how these tools stack up based on actual specs, it's invariable. This source gives us a really clear data-driven look.
Yeah, and what jumps out immediately looking at this tool is how it frames the comparison. It really zeroes in on two main things: signal-to-noise ratio, SNR, and, price.
Hmm.
You see this chart, right?
Right.
Where all the devices are plotted out based just on those two factors.
Exactly. SNR is just paramount. It tells you how clear the brain signal is compared to all the background noise. You need a higher SNR for cleaner data.
Yeah.
That's critical for many applications. And obviously, cost is a huge factor in who can actually get their hands on this tech.
Mm-hmm. And the data really seems to cluster these devices into the categories the tool itself highlights: consumer, research, clinical, and even implantable. And what the tool shows visually is this trade-off you pretty much always see.
Absolutely. The data makes it plain. The
Yeah.
consumer-grade stuff, usually lower price, yeah, but also lower SNR. Then you move towards the research and clinical systems, the price jumps way up, but hey, so does the SNR. Which makes sense, right? You need much more precise data there. Implantables are kind of their own beast right now, the frontier, really. Super high performance needed, but also super complex and costly to implant.
So if you filter the data using the tool, like just look at the clinical devices,
Right.
you see that cluster, right? Way higher price point, generally a much higher minimum SNR than the consumer gadgets. It helps you visualize, where the performance ceiling is for different budgets or uses.
And it highlights that basic choice you face with EEG tech. How good does the signal really need to be for what you want to do? And what are you willing to spend? Now, this tool simplifies things a bit, focusing on SNR and price. But remember, other specs matter too, like number of electrodes, sampling rate, crucial for different tasks. And the tool does mention wanting to add more dimensions later, which just underscores how complex this space really is. So many variables.
Okay, but here's where it gets really interesting, kind of points towards the future. The source mentions potential updates for the tool. Things like adding user reviews, maybe real-world performance data, moving beyond just the manufacturer specs. But it also makes a specific note about Neuralink. It highlights that it's designed as a bidirectional interface, meaning it can record and potentially stimulate, even though, current trials are just recording.
Yeah, that's fascinating. The bidirectional piece fundamentally changes the game. Most devices on this chart, they just listen, they record. But introducing stimulation, I mean, that shifts the potential applications completely. You go from passive monitoring to active intervention. It's definitely the bleeding edge. And it makes you wonder, how will future comparison tools even measure or compare devices when they can do such vastly different things?
Right. So, quick recap then. We've seen how this tool gives a data-driven snapshot of EEG devices. Using SNR and price, it shows those trade-offs and the clear groupings: consumer, research, clinical, implantable, helps you kind of map the market.
Hmm. And we've touched on how things are evolving, both the data we need to compare devices and the tech itself. We got a glimpse of a future where devices might not just listen, but talk back to the brain. So here's something to mull over. What does it really mean when this technology shifts from just recording signals to actively stimulating brain circuits? And how are we going to build tools to even capture the complexity of that future? Tools that factor in not just specs, but real-world impact, maybe novel things like that bidirectional capability.
Definitely a lot to think about as this field keeps racing forward. Thanks for diving deep with us today.